The paper is Fast Serializable MultiVersion Concurrency Control for Main Memory Database Systems. It's a 2015 paper. The summary of the paper is, the paper presents a novel MVCC implementation for main memory database systems that has very little overhead compared to serial execution with single version concurrency control, even when maintaining serializability guarantees. The novel idea is based on an adaptation of precision locking and verifies that the writes of recently committed transactions do not intersect with the read predicate space of a committing transaction. Paper experimentally shows that their MVCC model allows very fast processing of transactions with point accesses as well as read-heavy transactions, and that there is little need to prefer snapshot isolation over full serializability. Now, let's look at the evaluation methods used by the authors. Authors evaluate their MVCC implementation in hyper main memory database that supports SQL 92 queries and transactions and provide asset guarantees. TPCC and telecommunication application transaction processing, that is TATP benchmark, are used for different workload evaluations. To determine the cost of their serializability and validation approach, authors first measured the cost of predicate locking in isolation from predicate validation by running the TPCC and TATP benchmarks, each in a single serial stream. Following are the key contributions of the paper. A novel MVCC implementation that is integrated into high-performance hybrid OLTP and OLAP main memory database system Hyper. Paper's MVCC model creates very little overhead for both transactional and analytical workloads and thereby enables very fast and efficient logical transaction isolation for hybrid systems that support these workloads simultaneously. Based upon that, a novel approach to guarantee serializability for snapshot isolation that is both precise and cheap in terms of additional space consumption and validation time. The approach is based on an adaptation of precision locking and does not require explicit read locks, but still allows for more concurrency than two-phase locking. A synopsis-based approach to retain the high scan performance of single version systems for read-heavy analytical transactions, which are common in today's workloads. Extensive experiments that demonstrate the high performance and trade-offs of author's MVCC implementation. Now, let's give this paper a PS score. This paper has good parts and some intense parts, so on readability it gets 6 out of 10. It's 13 pages long, so on length it gets 9 out of 10. It'll be challenging to reproduce the findings, so it gets 7 out of 10. Industry value is decent, so it gets 7 out of 10. There are interesting results, so on learning meter it gets 7 out of 10. So the overall PS score is 7 out of 10.